Hello everyone, my name is Bryce Cazenave. I'm a research associate at Virginia Tech. Today we are going to talk about using remote sensing technologies to differentiate drought-tolerant recombinant inbred lines of peanuts. Peanut is an economically important crop in the US with a value estimated at $1.3 billion. It is very sensitive to drought events, which can affect yield and quality, and results in a loss of about $500 million annually. The development of drought-tolerant cultivars through breeding is therefore crucial for producers. It can be a reliable and cost-effective solution for rainfed productions. However, it requires phenotypic field testing to select lines based on traits, performances, and efficiencies, which is time-consuming, which is subjective and labor-intensive. The emergence and development of drone technologies is a reliable, accurate, and high-throughput alternative to manual measurements. The objectives in our study were first to phenotype a peanut recombinant inbred lines population to assess their pod yield under rainfed conditions, and then correlate the manual measurement with remote sensing technology-based data. For the material and methods, we use two checks, Bailey and Wynne. We use two parents to create a population of 342 drought-tolerant breeding lines. Our experimental design was an RCBD. We used two different locations, one in Suffolk, Virginia, and one in Lewiston, North Carolina. Our ground measurements were first an infrared thermometer to collect canopy temperature depressions, a green seeker to collect the normalized difference vegetation index, the NDVI, which is a health indices, and by the end of the growing season, the pod yield in kilogram per hectare. We also collected images from the sky using an Aztec Falcon 8 drone, which was equipped with different cameras. The first one was a Sony 6000 Alpha, which is an RGB camera, which stands for red, green, blue. And we could extract some RGB-based indices. We could also estimate the plant height using the RGB camera. Then we were using a Tetracam ASD camera to estimate the NDVI. And finally, we were using a FLIR TOW 2 thermal camera to collect canopy temperatures. Let's now check our result. The first figure is showing you the pod yield of the different reels. Here you have on the x-axis the different entries representing the different breeding lines, and on the y-axis you have the pod yield in kilogram per hectares. I sorted the different entries based on their pod yield, and I grouped them in 6 different clusters using the Ward method. To select the most efficient breeding lines, you would select the different cluster on the right side of the graph, the one in the red and the green clusters. The second figure is showing you the pod yield distribution of the reels, which is following a normal distribution. The red star is showing the average values of yield for the two checks which we used, Bailey and Wynne, which is at around 5,500 kg per hectares. The box plot on the top of the graph is showing you the variability within our study, with some outliers on the left and right side of the box plot. If we were to exclude the outliers, we would select breeding lines having a pod yield between 6,000 to 8,000 kg per hectare, which would be above the two checks that we used. Now on the right side, you will have a hierarchical clustering, which is using also the Ward method. It is a two-way clustering where you have vertically the different entries and horizontally you have the different traits that you use, such as the pod yield, but also the different remote sensing technology traits that we collected. Using that clustering method, you can group the different entries based on their efficiencies for each of those traits taken together. You end up having 6 different groups, such as the one we were having for the figure 1. The goal of this type of study is to check if the different group and the breeding lines within each group, each cluster, would be the same or more or less the same than the one you would obtain when you take only the pod yield, such as in the figure 1. We are also using a principal component analysis, which is showing the different variables and how they are correlated with each other, either evenly or lightly. So here you can see the different traits. You will have the pod yield here and the remote sensing trait more on the outside of the PCA. To determine which type of remote sensing trait you would select early in the growing season, which would give you the same information than the pod yield at the end of the growing season, what you would like to have is eventually the pod yield arriving at one area of the PCA, and at the same area you would have a remote sensing variable such as the NDVI as an example. Here, unfortunately, it is not the case. You see that the remote sensing data are differently placed as compared to the pod yield. If it was the case, however, and we're having a good pod yield and the NDVI as an example in the same area of the PCA, you could go in this graph and see which breeding lines would be affected and will give you a good yield. Now, as a take-home message, we saw that we were having an important variability in pod yield between the different breeding lines, that we could group them in different clusters, and we could select some clusters, such as the red and the green one, which are providing high-yielding breeding line under rain-fed conditions. And those yield would be above the one of the 2 checks that we used. The pod yield was following a normal distribution with outliers that could be removed. We use an hierarchical clustering and principal component analysis to highlight remote sensing traits, which can be used to select breeding lines of interest earlier in the season as compared to the pod yield at the end of the growing season. However, in our study, we were not having strong correlations between the pod yield and the technology data. What we are going to do in 2020 is to use additional traits manually measured or measured from the sky, from drone images, and try to identify reels which are exhibiting high yield under rain-fed conditions. This project was possible thanks to the USDA and the NIFA award. And I want also to thank the lab members which help us throughout this experiment. And I also want to thank every one of you which were listening to me. If you have any questions, you can email me using my email address on the top of the poster, and I would be very happy to send you some answers and information. Thank you very much.